Welcome to Golden Software's video training for Surfer 13. Surfer is a versatile gridding, contouring, and surface mapping software package. In this demonstration, I'll be covering gridding XYZ data to produce a grid file. Grid files are necessary to create 9 of the 13 map types in Surfer. A Surfer grid file is made up of grid nodes. Each grid node has a calculated Z value associated with it, and the nodes are evenly spaced in the X and Y directions. You can download grid files from the internet, such as USGS DEM files or SRTM data. You can produce grid files in other software such as Esri products, or you can transform irregularly spaced data points with X, Y, and Z coordinates into a grid file directly in Surfer. The transformation from data file into a grid file is called gridding. To grid an XYZ data file in Surfer, the data file must be organized so that the X, Y, and Z data are in 3 separate columns, and it must be saved in a supported data file format, such as a text file, a CSV file, a database file, or an Excel spreadsheet. Click Grid, Data. Select the data file, such as demogrid.dat, and click Open. In most cases, the default gridding parameters are suitable, and you can simply click OK to create the grid file, and then you can create some maps from the grid file. However, you can fully customize your gridding options to create the best grid possible for your data. I'll walk through the options presented in the Grid Data dialog. In the Data Column section, you can specify which columns in your data file are the X, Y, and Z columns. If you have duplicate data where the same XY point location has multiple Z values, or wish to apply a data exclusion filter, like to eliminate all data with a Z value in a particular range, click the Filter Data button. You can tell Surfer what to do with duplicate data, such as keep the first data point and discard the other duplicate data points, or you can choose to average the duplicate data points. You can also specify the tolerance for what Surfer would consider a duplicate data point, or you can enter a filter to exclude some data from gridding. For example, to exclude all data points in a file with a Z value of -999, enter Z equals -999 for the data exclusion filter, and click OK. If you don't remember which column contains the XYZ data, or need to refresh your memory on the data, click the View Data button to view the data. Close the View Data window by clicking on the red X in the upper right corner of the window. If you wish to create a statistics report about your data, click the Statistics button and a Data Statistics report is generated. Close the report by clicking on the red X in the upper right corner. If the Grid Report checkbox is checked, Surfer will generate a report after gridding is completed with information and statistics about your data and the grid file created. I will uncheck this box to not create the grid report. The next section is to select the gridding method and options. Surfer offers you a choice of 12 gridding methods. What you choose for the gridding method will depend greatly on your data and what you would like the output to look like. There is no one best gridding method to use for all datasets or for any particular type of industry. However, there are some instances where some gridding methods may be more suitable than others. The default gridding method, krigging with a linear variogram, was selected as a good default method as it produces a good-looking map for the majority of datasets. However, it is not an exact interpolator and can extrapolate grid values beyond your data's original Z range. For example, if your data goes from 0 to 100, the Z range of your grid file may be 5 to 105. If you wish to use a more exact interpolator that does not extrapolate Z values beyond the range of data, you can try inverse distance to a power, natural neighbor, nearest neighbor, or triangulation with linear interpolation gridding methods. If you look at the map produced with the krigging gridding method, but wish to include a fault file containing fault traces, then minimum curvature might be the best option for you. If your data is already on a regularly spaced grid, you might want to try the nearest neighbor gridding method, setting the grid spacing to be the same as the spacing of your data points. There are many reasons why you might choose one gridding method over another. Each map will look slightly different with each gridding method, and it really is up to the personal preference of the user. I will choose inverse distance to a power. Once you have selected a gridding method, you can access additional options for the gridding method chosen by clicking the Advanced Options button. The options available under Advanced Options will change depending on the gridding method selected. Some of the more common options include a general page that has gridding method-specific options, and in some cases, an anisotropy section, which allows you to specify the ratio and angle for the preferred orientation in the data. The search page controls which data points are considered by the gridding operation when interpolating the z-value of grid nodes. If you have fewer than 250 data points, usually the no search option is most appropriate, and the gridding algorithm uses all the data to calculate the grid node z-values. If you have between 250 and 10,000 data points, then the default is to use a search. But you still have the option to check it to specify no search if you want. If you have more than 10,000 data points, you must use a search. The search rules define the number of data points to include when interpolating a grid node z-value. The search ellipse defines the shape and size of the searchable area around each grid node to use to calculate that grid node's z-value. Data points that fall outside of the search ellipse for a grid node are not considered when calculating that grid node's z-value. If no data points fall within the search ellipse, then that grid node is blanked. The units of the search ellipse are the same as the x and y units in your data file. I will recheck no search. The break lines, or break lines and faults page, allows you to include a break line or fault file when gridding data. The break line and fault lines must be saved in BLN format to use during gridding. Some gridding methods support break lines, some support break lines and faults, and some do not support either of them. Break lines occur when there are changes in slope on either side of the line. This might be at the top of a ridge or at the bottom of a riverbed. Break lines have x, y, and z values for each vertex in the line in the BLN file. This is the only time where z information is used in a BLN file. Surfer can look across the break line to the other side for data points to use when calculating grid nodes. The XYZ points of the breakline BLN file are also included as data points during gridding. Faults, on the other hand, occur when there are differences in z values on either side of a line. This could be because of a geologic fault or another reason, such as a landslide or a concrete wall. Faults only have x and y values in the BLN file. Surfer sees the fault as a stop when gridding. It cannot look across the fault to the other side for data. It can go around the fault, but the distance will increase and the data on the other side of the fault will have less of an effect on the grid node values. To select a break line or fault file, simply click the yellow open folder icon, select the BLN file, such as demoslice.bln, and click Open. Adjust any of the advanced options you wish and click OK. Click the Cross-Validate button to perform cross-validation on your data. Generally, cross-section validation can be considered an objective method of assessing the quality of a gridding method or to compare the relative quality of two or more candidate gridding methods. In Surfer, cross-validation can be used with all gridding methods. You can save the results file by specifying the file name and location in the cross-validation results file section. For details and more information on cross-validation parameters, please click the Help button to open the cross-validation help page. The grid line geometry section allows you to specify the extents and resolution of the grid nodes in the grid file. You can choose to set a particular x and y minimum and maximum value for the grid file, which is useful if you are trying to match the extents to another grid file, or if you want the grid to be exactly a particular size. You can also choose the grid spacing, which is the spacing between grid nodes. The spacing is directly tied to the number of nodes. The smaller the grid spacing, the more grid nodes you will have. A higher number of grid nodes will increase the resolution of your grid and vice versa. By default, Surfer sets 100 grid nodes in the longest direction, the spacing values between the directions to be equal, and then calculates the number of grid lines in the shorter direction. You can increase the number of nodes number up to 2 billion grid nodes. However, the computer will run out of memory long before you can create a grid that large. The more grid nodes you have, the more memory it takes to create the grid file. The Grid Z Limits section is new in Surfer 13. It allows you to limit the Z values in the grid file to a specific minimum and maximum. For example, some gridding methods, like krigging, can extrapolate the Z values in a grid beyond the range of actual data in the data file. You may not want this. When the minimum and maximum are set to none, this allows the Z range in the grid file to be determined by the gridding method. if you want the z-range in the grid file to exactly match the z-range of the original data file, change the minimum and maximum sections from none to data min. If you would rather limit the z-values in the grid to another set of values, you can change the minimum and maximum to custom, and then enter the values you wish to use to limit the z-range. This would be useful if you understand the z-range in the data file may not be the z-range for the grid, but that the z-min or max in the grid should definitely not go beyond another particular value. For example, if the z-min in the data file is 10, and you know that there simply should not be negative z-values in the grid file, you can enter 0 for the custom minimum value and set the maximum value back to none. Surfer also offers the option to transform the z-value to logarithmic. You can leave the z-transform set to linear, and there is no change to the z-values of the data you are gridding. If you choose log save as log, then this converts the z-value in your data file to logarithmic, grids the logarithmic data, and saves the grid with the logarithmic z-values. If you choose log save as linear, then this converts the z-value in your data file to logarithmic, grids the logarithmic data, converts the z-value in the grid back to have a linear value, and then saves the grid with the linear z-values. This is very useful if your data is logarithmically distributed, but you want to keep the actual original z-values in the grid file. For now, I will keep it set to linear. The blank grid outside convex hull of data option automatically blanks the grid outside of the convex hull of the data. The convex hull is the outer perimeter of all your data points. Uncheck the box to extrapolate the grid data to the minimum and maximum grid limits, regardless of whether data exists in these areas. Check the box to only calculate data in the grid within the original data point boundary. When you blank a grid outside of the convex hull of the data, there is also the option to inflate or deflate the convex hull. This allows you to blank a grid a specified distance inside or outside the convex hull of the data, and not exactly at the data point boundary. Positive values will inflate the convex hull, and negative values will deflate the convex hull. The units are the same as the horizontal data units. The Output Grid File section allows you to specify the output grid file name and file path. By default, Surfer will create a Surfer grid file. However, you can click the yellow Open Folder icon, browse to any file location, type in or edit the file name, and choose any of the supported grid formats to save in. Click Save to save the changes. When you are finished setting your gridding parameters, click OK to create the grid file. You will be notified when the grid file is created, and, if specified, the grid report will open. The grid can now be used to create maps, calculate volumes and areas, or perform other grid functions. To see the results, you can create a map by clicking Map, New, Image Map, select the grid file created, and click Open. This concludes the video training for gridding data in Surfer 13. If you have any questions, please contact Golden Software.